Hello, sir.
Hello, Radhika. Sure. The question we have done this question, na? Acha, let us solve some more question on work power energy. Acha, let me tell you something about Acha, I did not tell you something about the potential energy. Potential energy. I feel I told something about potential energy when I was talking about the conservative forces. This thing I have told now. Do you remember? Potential energy in a spring is half kx square when it is expanded or compressed, and mgh is the potential energy for gravity. Okay, na? Remember these things? Do you remember na these things? Haripriya, Radhika,
Yes.
Kanishka. Okay. Acha, now let me give you a question on this for you. Try solving this question.
So what should be the answer?
What answer you are getting?
2 point.
No, 67 they are saying. Spring constant is 67. Let's see what they have, what others are doing. Radhika, Kanishka, are you getting the answer? 67. What do you want me to solve? Shyama, this is I have just given this question. Try solving this. Since you know the concepts, you must be able to solve this. नहीं भैया 67 है आंसर. तुम्हारा आंसर वर्किंग भेजो एक बार. ठीक है.
66.667.
अच्छा. Let me show you, Haripriya, how this is done. So you'll get the idea. See, the block is fastened to a horizontal spring. The block is pulled by. What is the situation? Let me explain you the situation first. The block is fastened to the horizontal spring like this. Okay, block, this was its original position when the spring was not expanded nor it was compressed. Block is pulled by a distance 10 centimeter. Now it is pulled to a distance of 10 centimeter here. Now it has come to this position. On a frictionless surface from rest, energy of the block is x is equal to 5 centimeter, means energy of the block at this position, x is equal to 5, is 0.2. This is the total energy they are saying. Spring constant they are asking. See, at this position when it was touched till here at this particular position, it was stretched and it was just left from the start. So at this particular position, it will have only the potential energy because it has been expanded. What is its potential energy? Half k x square. Since it is at rest here, it will have no velocity. U is 0, so kinetic energy is 0. Okay. At this particular position, Haripriya, at this particular position, it is expanded still. But why? What is distance? 5 centimeter. Let's say it is x2. So here also it will have some potential energy, half k into x2 square. But since now it from this position it has been left.
We'll have to calculate both spring potential and kinetic and equate. That's it.
Yes, but you need to know now that Haripriya need to know that why this will have velocity here, because from there it was left as it is. Now it will, when it is left as it is, it will start moving, and here it will have some velocity. So it will have the velocity half mv square also. Okay. And this total energy they have given, this energy is equal to this total energy, potential energy plus kinetic energy they have given, this is equal to 0.25 joule. So we'll do the law of conservation of energy. Law of conservation of energy. Why we'll do law of conservation of energy? Because there is only one conservative force acting. This is spring force. No other force is acting. So initial at this position, the total energy, which is half k x1 square, will be equal to the final at this position, the total energy, the second position, which is total energy is given to us. So I need not write each value, and need not calculate. I'll just write this as 0.25 joule. So 1 by 2 k into x1 value is what? 10. 0.1 whole square is equal
Then
to
I
0.
forgot the whole square.
Silly mistake you have done. K is equal to 2 into 0.25 whole divided by 0.01. Get the answer. But I am getting 50.
Yes, sir. That's I was thinking how can the root of this thing be like 60 or something?
What is this?
Yeah, sir. You get 50 only.
50 only will get. राधिका तुम्हारा कैसे आया?
मैंने कोई कुछ गलत करा मेरा 66.67 आया
पता नहीं. तुमने ऐसे तो नहीं किया इसको कि कहीं तुमने जो टोटल जो एनर्जी ऑफ द ब्लॉक एट एक्स इज इक्वल टू 5 सेंटीमीटर जो दिया हुआ है वो काइनेटिक एनर्जी ले लिया? I think if we take this as kinetic energy, then we may get this
फाइनल
value.
काइनेटिक एनर्जी मैंने 0.25 जूल किया
Let me check. If I take half mv square as 0.25 joule, half k into 0. I think,
How the other person.
Shyam, I think this, if we do this one, we'll get that. But they have to actually specify.
Yes, sir, because they need to like consider if there's velocity of block or something.
Hmm.
They're not given anything. I also got confused, like something should be given, it's like incomplete.
This is incomplete. Actually, they should have given it as.
Hmm.
Then we'll get the answer. I think that answer is, yeah, it's 0.25. Now you'll get it. Okay. One minus 0.25 into 100. 0.75. 25 into 2 by 75 into 100. Now we are getting now 66.67. 67. Newton per meter. Don't worry, but according to the statement they have given, na, if they would have given kinetic energy only, then we should have solved this in this way, like I have solved just now. Taking kinetic energy as 0.2, half mv square as 0.25, and this.
So,
If,
but this is a JEE question, no, sir. So,
what happens, na, Shama, in these, when these kinds of things are there, the question becomes controversial. In that case, they have to award total marks.
oh,
When someone if someone disputes it now, and many students will be disputing it. Suppose, see, if you are studying, you 3 or 4 students are studying with me, I'll say this can happen, there are two cases, so you will all dispute this question. Like this, another coaching institute also, you will tell to your say this to your friends also, they will understand, oh, this can happen, so they can dispute this question. So when many of the students dispute the question, then they have to award the award 4 marks to this, because it, but the reason should be logical. It's logical reason, because they have to specify what kind of energy it is, kinetic energy or total energy. If nothing is given, we take it as total energy only. Try to do this one.
so root 3 meters.
Root 3 meters. Wait. No, they are getting, no, answer is 2 meters.
So we must use range formula, no?
No, not necessary. The range formula is not needed. It's purely work energy theorem. Here, when it is compressed, it will have potential energy only at this position.
And then it gets converted to kinetic energy.
It will then convert it to kinetic energy.
So we'll get V square. From that, it is moving on an.
When it will move to the top position, it will stop. There only it will have potential energy. If you want, see, it's a very big hint that now here, if it has, see, if we,
There is it 2 meters?
Here, if it has half kx square, if we make law of conservation of energy till here, it will be equal to half mv square. But again, if we make law of conservation of energy between this position, B position to the top position, so it will be equal to here mgh. Half mv square will be equal to mgh.
Okay, I understood. I forgot to equate half mv square.
So no, it's not needed only. Half mv square is not needed.
So half kx square equals half mgh. Okay, sir. So I thought the maximum distance means the total range it covered. I thought.
This distance, or they are asking this
We are
distance only.
talking about the distance.
Oh,
Not
the
the
incline distance. Okay, then I understand. I thought they're asking about the after it pushed how much distance it traveled. I thought.
Not that one.
Then it will be 2 meters.
2 meters. Huh? It's not that difficult. The question is not difficult. Half kx square will be equal to mgh. You will just equate them, put the values, and here this h will be equal to d sine theta. That's all. D by 2. So you'll get the value d is equal to 2h.
Yes.
These are the two equations that you will be using, 1 and 2.
So can you give more problem?
I'm giving you a problem. Wait. I was making sure you understood or not. I'll give you good
Can
quality.
you send a so I told you send a worksheet for basic calc based on the portion.
Oh, I forgot actually. I'll see in the evening, in the night. I forgot actually. You could remind me, na? I forgot.
Okay.
In that case, when I forget to send you, na, you just remind me.
Okay. So you could do it today, I guess.
Today at night, I'll send you. क्या हुआ भाई question?
So this question I solved it in school.
Solve it now. If you know, give me the answer.
what is this? The diagram only looks so complicated.
No, but it's not complicated. It's easy only. Don't fear. It's not that difficult. It's easy. Just you need to understand.
Sir, I'll refer my class notes. We did this same
No,
question.
no, no, don't refer it. If you have done it, you should you
I
should
remember
know.
how I did it, sir. I remember how.
Then do it and then solve and give me the answer.
Sir, how to do this?
Array, see, this is actually you think the question, this diagram is complicated, so it will be difficult. See what the question is. One end of a light spring of natural length d. This spring has natural length d, right? Spring constant
Sir,
is
I
Sir,
know
k.
is
how to do it. Sir, first at the top point it will be mgh, sir.
Huh?
And then as the ring, as we leave it from rest, the ring moved down.
Correct.
So we could write it as d will be constant, h square, l square. It's a right angle triangle.
Hmm.
So L d square plus h square equals L square.
Hmm.
And we could differentiate it on both sides.
No, not needed.
That was simpler actually. And then
Hmm.
oh, I remember this question. I did it in school also, correct?
No,
Like,
no, no. Differentiation is not required actually. Yeah. Because friction is not there, na? Without friction it is. So there are only conservative forces are acting. See, I'll explain you in detail everything.
so sir, can I join in 2 minutes, sir? Like,
Ah,
I'll
okay.
come in 2 minutes at 3 minutes.
You refer your notes.
No, sir, I won't. I'll just go 1 second, sir.
Okay, okay, okay. See, what is the thing? Let me explain the question. One end of a light spring of natural length d and spring constant k is fixed on a rigid wall. This is your rigid wall. Other is attached to a smooth ring of mass m. This is your ring, which can slide without friction. It can slide up and down without the friction. There is no friction between the ring and this. Now, this distance they have said d. See, you have to be here. You have to now observe this properly. See, they have given the spring of natural length is d. Means without expansion, its length is d. This distance they have given as d. So obviously, when it will fall, when this ring will fall, it will reach here. At this particular point, there won't be any expansion in the spring, right? This point you understood? So there won't be any potential energy here for the spring, right? Radhika, Haripriya, Kanishka.
yes.
Okay. Initially, the spring makes an angle of 37 degrees. This they have given. When the system is released from rest, initially its velocity is 0. It's released from rest. Find the speed of the ring when the spring becomes horizontal. Now see what concept you have to apply. Obviously, at point A, this spring is stretched. By how much distance it is stretched, we do not know. That you have to calculate. If you want, you can just calculate it using x1 is equal to L minus D. Okay? At this point, the length is L, na? Oh yeah, no one is saying I'm something. Is it difficult? See, you will understand it's not difficult. Actually, the expansion in this string will be its length minus this natural length. D is the natural length, na? So expansion here will be L minus D. So at this point, when it is expanded, it will have some
You're
potential.
finding the expansion length.
At this point, it will have some potential energy because it is expanded from natural length, but no kinetic energy, 0. At this point, bottom point B, since the spring natural length was d, there is no expansion or compression here, so this potential energy will be 0, but here kinetic energy will be there. And you have to do law of conservation of energy between the points A and B. That's all. Why we are doing a law of conservation of energy? Because here only conservative force is acting. The conservative force is mg. Only this conservative force is acting. One more potential energy is there at this point, mgh. If we take this as the reference, mgh is there. So because of mg also one potential energy is there. One due to spring, one due to mg, kinetic energy 0. Here 0, potential energy also 0, half mv square. Why we are doing conservation of energy? Because only mg is there. Mg is conservative force. That's why rest all no friction is there, because they have given friction is not there. So we can safely apply law of conservation of energy here. Between point A and B, we'll equate half k x1 square plus kinetic energy is 0. This is kinetic energy. Plus potential energy at this point mgh is equal to potential energy. Mgh part is also 0. H is 0 because here at B, that is. Half kx square is also 0 because expansion is 0. For your understanding, I have done like this. Half mv square is there only. You have to solve this and get the answer. But you have to write the value of h in terms of d only, because only d is given. X1 you have to find. You can find using x1 is equal. L is what? D by sine 37, na? D by cos 37, sorry. Wait. D by L. This is L minus D. You will get x1. H, how you will find? H is equal to D tan 37. You have to put these values and solve. You will get the answer. Was it difficult? Do not know where Shama has gone, but how, I don't know how he was doing using the law or this one differentiation. I think he must have remembered some other question. Haripriya, tell me, was it difficult?
No.
It was easy only, no? I don't know why. Radhika, मुश्किल था क्या?
थोड़ा कंफ्यूजिंग था, बट अब ठीक है।
डायग्राम देख के घबरा जाते हो। अच्छा, एक बात बताओ मुझे, राधिका एंड हरिप्रिया, और कनिष्का, आई थिंक कनिष्का वाज एब्सेंट ड्यूरिंग दैट टाइम. Did I tell something about the springs in series, springs in parallel? That concept did I explain?
I don't think so.
अच्छा, okay. I'll explain you springs in series, springs in parallel also. You get the answer? What happened? Did you get the answer? Radhika? Haripriya, are you getting the answer?
No, sir.
Okay. What happened? See, let me do it.
Sir, will we kind of get anything in fractions?
No, it's answer. Answer is actually different. You will be getting the answer in terms of D, like this kind of answer you'll be getting. V is equal to D root over 3G by 2D plus K by 16M.
I'm nowhere near that, sir.
So let me show you it. How do you get it? Half K, X1 is what? Let me solve this one. X1 is D cos 37. Cos 37 is 4 by 5.
5D by 4 minus
5D by 4 minus D, so it will be D by 4. So D square by 4 square. Let's write it as D square by 16 plus mg, which is D tan 37. So it will be 3 by 4 is equal to half mv square. Acha. If we cancel this 2, it will be kd square by 16 plus 3 mg d by 2 is equal to mv square. So now it's very easy. Kd square by 16m plus 3g d by 2 is equal to v square. To take the d square common from this, it will become d square into k by 16m plus 3g by 2d. This is equal to v square.
You got
So I got the answer. But why you are not getting the answer?
I don't know, sir, what I have.
You actually see it's only psychology. What you thought na everyone. The Shama has left away. He's not coming back. I don't know what happened. Got fear or something. Everyone, you thought that this question is very difficult. The diagram is looking very difficult type of question, so we won't be able to solve. So that's why you are making these kinds of mistakes even after explaining. Otherwise, more difficult calculation you have already done. Acha, after this, let me not solve the question. Kanishka तो बोल ही नहीं रही है भैया. I think I have given tougher question, right? I'll give you easier questions then. Do you want me to give easy?
Anything is fine.
It's not difficult. Let me tell you, it's not difficult. But since it's new to you, you may be feeling somewhat. It's not difficult. You need to just understand. Once you get the idea, what concept you have to apply, it will become easy. V is equal to d over k by 16m plus 3g by 2d. Acha, now let's not solve this question. Let me explain this concept I was telling you. Springs in series and springs in parallel. This is the case of springs in series. This K1, which is K2. See, what is the thing now? This setup is known as the springs in series. Now, when you replace this one with only one spring, then the spring constant for this is given as K1 plus K2. And when the springs are in parallel, when we replace two springs with one, now when the case is like this, one spring is there, other spring is also there, K1, K2, they are connected and this mass is there. If you try to replace this part with one system, it will become K effective will be equal to K1 K2 by K1 plus K2, or 1 by K effective is equal to
So this
1 by.
thing like memorize.
This you can memorize. If you want, I can explain you also why we are getting this kind of thing. Did you memorize it?
No, so I guess we are about to come to this part.
Why do we get this result now? Because see, when we expand, when we move this part by x distance, the forces which are acting to the spring is K1x. Expansion in K1 will be also x and K2 also will be x. So the net force acting on the block M will be K1x plus K2x. Now if I take this as one spring, K effective, I have to displace this by same distance x. Here force will be K effective into x. Now these two are same setup. So K effective into x must be equal to K1 x plus K2x. So K effective into x is equal to K1 plus K2 into x. So I have to just remove x here. This is how we get the result. Now in the case of parallel, there is different thing. If this spring is moving down by x1, this spring may be moving down by x2. The net expansion here, the net drop down for M is x1 plus x2. Here it will be x1 plus x2. Okay. But the thing here is, since they are joined, these two springs have joined, the force due to this spring at this point, K1 x1, should be equal to K2 x2 here. So we have the condition because they are the same, they are connected line by line. So tension in both the points should be same. Otherwise, how can it be? So K1 x1 should be equal to K2 x2 should be equal to, that's all. And this should be equal to K effective into x1 plus x2. Okay. Let's equate this with some force F, some constant. So x1 will be equal to F by K1, x2 will be equal to F by K2, and K effective, and x1 plus x2 will be equal to F by K effective. If you put it here in this third equation, x1 x2 value, it will be F by K1 plus F by K2, F by K effective. So that's why we get the result. 1 by K effective will be equal to 1 by K1 plus 1 by K2. This is a dummy value, dummy thing that I have equated. If you want, you can take some lambda also here. This thing makes the questions very easy when you are changing the springs in series with one spring, K effective. When you are changing these two springs with one spring, it becomes K effective is this. The reason why I have explained you. Okay. Now your thing is, Shama, I have solved this question. You can see in the recordings. I'll send you.
Yes, sir, we have solved it in class, sir.
But you were solving, did you get this answer?
Yes, sir, we got that. Yeah, I got it.
But this you won't be able to solve using differentiation.
Okay.
This question is your homework. You can solve as at home. Okay, let's end the class now.
Okay. So can you send the homework questions separately?
I'll send you.
Fine.